Hello. So today I was trying to learn about and teach about this design pattern. So design patterns are, as we know, kind of very useful in interviews. So let's understand design patterns. It is a kind of safe learning. So here you can join and read and teach, understand together, nothing more than. So this website is very popular with factoring.guru design patterns. Design patterns. Here we have design patterns are typical solutions to common problems in software and design. Each pattern is like a blueprint that you can customize to solve a particular design problem in code. So what are design patterns? Design patterns are typical solutions to common problems in software engineering. Each pattern is like blueprint that you can customize to solve a particular design. So today March 18, 2026. Now we are going to deal with design patterns. Cool. So here we learned about what is design pattern. Basically, it is a typical solution to common problems in software design. Each pattern is like a blueprint that you can customize to solve a particular design problem in your code. What's design pattern? Benefits of design pattern, you can see patterns are a toolkit for solutions to common problems in a software design. They define a common language that helps your team communicate more efficiently. Classification. Design patterns differ by their complexity, level of detail, and scale of applicability. In addition, they can be categorized by their intent of divided into three groups. So there are different three groups. We will see that what are different groups are there. Actually, structural, behavior, and one more is creational, I think. Then catalog of pattern, list of 22 classic design patterns grouped by the intent. And then we can see history of the patterns, what history, who invented patterns and when. Can you use patterns outside software development? How do you do that? And dive into design patterns, check out their ebook design. There are different books. And then criticism of patterns. All patterns are as good as advertised. Is it always possible to use them? Can patterns sometimes be harmful? So if it can be harmful or not. Okay, now let's see what's design pattern. And then, do I need to sign in inside it? Okay, no. So Look here, classification of design patterns have different types. You can see creational patterns, structural patterns, and behavioral patterns. So let's take these examples. So let's understand these examples. Cool guys. So here let's understand creational pattern. What is creational pattern? So here can see provide object creation mechanisms that increase flexibility and reuse of existing code. Then let's understand again creational patterns provide object creation mechanism that increase flexibility and reuse of existing code. So basically it provides object creation mechanisms. And then what is structural patterns? Explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. So creational patterns tells about the different mechanisms for object creation that, that increase flexibility and use of existing code. So basically creational pattern deals with the object creation. You can notice down like let me write down also creational patterns are related to creation of object, right? Creation of object creation. Object creation mechanisms. Okay, structural patterns explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. Explain how to assemble objects. So basically, structural patterns explain about assembling of the object and classes, right? Structural pattern explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. Flexible and efficient. You can see it is flexible and efficient. So flexible and efficient. Flexible and efficient. And and then we have behavioral patterns takes care of effective communication and the assignment of responsibilities between two objects. So behavioral patterns, what they deal with, in simple words, they take care of effective communication. So basically it's related to communication between objects. and the assignment of responsibilities between objects. So one is related to object creation, which is creational pattern, and then structural patterns we have. This is assembling of the objects, assembling of objects, right? And classes into larger structures. Now let's read this one. So let's see creational patterns. Here you can see the catalog of design patterns is creational patterns. Cool. Catalog of design patterns. So creation patterns provide various object creation mechanisms where increase flexibility and reuse of existing code. These patterns explain how to assemble objects or classes into larger. Mhm. While keeping these flexible and efficient code and behavioral patterns. You can see here the patterns are concerned with algorithms and assignment of the responsibilities between them. So, wow, what a wonderful way. So here all the design patterns which are very popular, they are here. If you can see, cool. So here you can see factory method, different design patterns which are popular one. The catalog of the factory patterns, abstract factory. Most commonly these are asked in interview questions with senior developer, or if you are going to look for senior case. In that scenario, it is going to be the catalog of design patterns or creation patterns. Here you can see factory method, abstract factory, adapter, bridge, chain of responsibility, command, iterator, mediator, builder pattern, prototype, composite, decorator, memento, observer, state, strategy pattern, very popular one, this is strategy pattern, and then singleton, and then we have what is this? Facade. Why it is gap here? Okay. Oh, got it. So there is a gap to understand about this, like which one is structural, which one is behavioral, something like that. I was reading random, but it is not like that. It should be like these five are creational patterns. Which one? The factory method, abstract factory, builder, prototype, and singleton. These five are creational patterns. So let's jot it down. Creational patterns. Creational patterns. What are these? These are first let me write the singleton pattern because it is singleton pattern. Then we have factory pattern, and then we have second. हाँ जी ऐसे ही है बैठा हुआ हूँ कुर्सी पे काम चल रहा है हम्म खाए तो खाए सुबह में चलिए लगेगा तो खा लेंगे कोई दिक्कत नहीं ना अपने खाए अच्छा था, मैं तो खाया था, पूरा खा लिया मिर्च उर्च डाल के ये अलग से। हम्म, चलिए कोई बात नहीं। कितने बजे निकलना है, फ्लाइट आखिरी कब है? चलिए ठीक। ठीक आइए। Cool. So we have factory, then abstract factory, then builder. For abstract creational patterns, we are having these five ones: builder, prototype, and singleton. So I'm just writing them down: builder, prototype, and singleton. So these five are the creational one. Then we have structural patterns. Structural pattern, these patterns explain how to assemble objects and classes into larger structures while keeping these structures flexible and efficient. So what are the structural patterns? You can see a lot of these are popular one are, which I remember: conductor, then bridge, and then composite, then decorator, and facade, flygate, facade, and then fly, W-I-G-S-T, flygate, and then proxy. And then after that, we have behavioral patterns. These patterns are concerned with algorithms and assignment of responsibilities between objects. So here you can see the behavioral patterns. They are connected, they are mostly concerned with the algorithms and the assignment of responsibilities between objects. So what are these? You can see चलो भाई एक एक को धीरे धीरे से रगड़ते हैं। बिहेवियर पैटर्न्स में क्या क्या है? चेन ऑफ रिस्पॉन्सिबिलिटी, कमांड, इटरेटर, मीडिएटर, momento, observer. This is popular one. Observer pattern I have heard. And then command pattern, chain of responsibility. I've never got into any interviews. And then we have strategy patterns. It is just strategy patterns I have seen. And then this proxy out of this adapter is very popular. Uh, Structural adapter and facade are popular. They are asked in interviews. And creational, mostly all are kind of this prototype. I have not been asked in interviews. But other than that, if you see Singleton, facade, flyway, template, and visit. Cool. So let's go first for the creation. We will not cover all these because there are a lot of design patterns. We will mostly cover the popular ones, which are asked in good companies, in big companies actually, which are popular these days. So first, let's start with singleton design pattern because I know what it is. So here intent is, you can see singleton is a creational design pattern that lets you ensure that a class has only one instance while providing a global access point to this instance. So entirely here you can this diagram is very much self-describing. Actually, there is one boss and then there are different followers. So the same thing it is saying, like singleton is a creational design pattern that lets you ensure that class has only one instance while providing a global access point to this instance. Just like you can see here, problem is the singleton pattern solves two problems at the same time, violating the single responsibility principle. Okay, ensure that a class has just a single instance. Why would anyone want to control how many instances a class has? The most common reason for this is to control access to some shared resource, for example, a database or a file. It is correct actually. Here's how it works. Imagine that you created an object, but after a while decided to create a new one. Instead of receiving a fresh object, you get the one you already created. Note that this behavior is impossible to implement with a regular constructor, since constructor call must always return a new object by design. सही बात है. When we call constructor, it always creates and initializes basically new object. So note that this behavior is impossible to implement with a regular constructor, since constructor call must always return a new object by design. So here you can see in the diagram, clients may not even realize that they are working with same object all the time. Here you can see the, sorry, I thought this room wasn't occupied. But whenever this client opens the door from anywhere, if you see in the diagram, if he will open, he will get this single instance, the one which is inside the room, right? So there is only single instance, and every time the client goes and want to talk, क्या होगा कि इस चीज़ को मिलेगा, हर बार यही ऑब्जेक्ट मिलेगा. So basically single instance is there. Single instance. Cool. Just like a king, a PM database connection is generally we have single instance for that. Provide a global access. Here you can see provide a global access point to the instance. Remember those global variables that you, alright, me used to store some essential objects. While they are very handy, they are also unsafe. Right, they are also very unsafe. Since any code can potentially rewrite the contents of these variables and crash the app, just like a global variable, a single button lets you access some objects from anywhere in the program. However, it also protects the instance from being overridden by other code. It also protects the instance from being overridden by other code. It also protects the instance from being overridden by the code. It also protects the instance from being overridden by the code. It also Cool. Now you see there's another side to this problem. You don't want the code to solve problem number one to be scattered all over your code, right? It's much better to have this within a single class. So you can see solution is all implementation of the singleton have these two steps in common. Make the default constructor private. So constructor is going to be private. You can see this there is a constructor and this is going to be private. And then to prevent other objects from using the new operator with a singleton class. So basically they cannot create the object using this private constructor because private constructor is not available to create the object. Create a static creation method that acts as a constructor. Now what we need to do, we need to create a static creation method that acts as a constructor under the hood. This method calls the private constructor to create an object and saves it in a static field. All following calls to this method return to the cached object. If your code has a singleton class, then it's able to call the singleton static method. So whenever that method is called, the same object is returned. So basically what it is saying, while designing a class, your constructors should be private and then there should be a static method which would be returning the instance from that. So here in the code you can see if instance is equal to null, in that case instance is equal to new singleton. Note, if you are creating an app with a multi-threading support, you should place a thread lock here and then return response. So let's see the pseudocode. Here you can see in this example the database connection acts as a singleton. Database, we have database, this class is singleton. I think this is written in Kotlin, right? Okay. So we have this instance and then we have a private constructor which is very important, and then there is a check, the static method that controls access to the singleton. So we have a static method get instance which is going to be if data, which is going to check if database.instance is equal to null, then acquire the lock and then ensure that the instance haven't yet been initialized by any other thread, while this one has been waiting for the lock's release. So if database.instance is equal to null, then database.instance, we are basically creating a new instance and then returning the same instance. So this is simple one in the Java, since we are Java guys. So let me show you some Java code here. Singleton design pattern Java. So here you can see key principles for making a singleton: private constructor, private static instance, public static method. So that method get instance which we use, it should be public, and it was public actually. I didn't mention it, but yeah, it was public here. Let me show you. It is public. Static, you can see this is public method. Static and then public. Cool. And the constructor is private. This is the condition for making singleton class or singleton object. Common implementation using the implementation methods, you can see lazy initialization. You can create the instance on demand, saving resources, but is not thread safe. Thread safe double check the locking, uses synchronized blocks and volatile variables to handle concurrency efficiently. Will pop क्या पढ़ता है? Singleton utilizes a static inner helper class for lazy initialization that is both efficient and thread safe. And then we have enum singleton recommended by Joshua Block for simplicity, guaranteed thread safety, protection against reflection and serialization issues. So we have enum singleton, right? So let's dive deeper into this one. today we are mostly going to understand design patterns. So here uh, let's see the code. Yeah. So the best practice you can see it is enum singleton. Enum recommended by experts like Joseph Law. This is the most robust implementation. It is natively thread safe and provides built-in protection against reflection and serialization attacks that can break the singleton. So here you can see we have simple enum class, enum singleton, and there is an instance, and we have add your business logic here. So basically we have this whatever we are doing we can have that here, and then we can call enum singleton dot instance, then do something. Then there is static inner helper class. We are not gonna look into that. Private construct prevents external instances which we know. Then it is private static will how can you it's okay. And then class lazy loading. But I was wanted to talk about enum, which we talked already, this one, and then this lazy loading thread mechanism. If you need to perform, if you need to perform complex logic during initialization, use double check logic. This is very famous in interviews. Interviewers, this is the the what you can say most handy tool for interview from the threads. They generally ask this question if they are if they are dealing with design patterns, then also, and if they are not dealing with design patterns, then also classy lazy classy lazy loading, because you need to perform complex logic during inference. So the volatile keyboard you can see here, it is a picture. Typically get into the instance it correctly handled across different threads. So private static volatile thread safe singleton instance. Volatile resource changes are visible across all the threads. So private static volatile thread safe singleton, we have instance, and then we have private constructor, and then a public static method which gets instance. And how it is going to get that? First, it is checking if instance is equal to null. First check, no locking, just check. First check, no locking. Second check, with locking. ठीक, तो क्या करना है? If instance is equal to null, just remember these two lines. First check without locking, no locking. Second check with locking. We have to double check. That's why it is called double check. So look here, we have public static thread safe singleton get instance, and then if instance is equal to null, use synchronized, then object. You can see this is class level lock thread safe singleton dot class, and if instance is equal to null, do what? Second check with locking. Instance is equal to new thread safe singleton. So if instance is equal to null, second check with locking, you can see again we are double checking for the null. First we are checking instance is null, and when we acquired the lock, again we are checking if instance is equal to null. Basically, second check or second check with locking, instance is equal to, now we are going to create the instance new thread safe singleton. So this is private constructor. Now it is going to create and give us the singleton instance. So nowhere it is going to create a double instance. In the end of this method, we are returning the instance. There's nothing much to do. Okay, and there is an eager initialization also. The only difference is like when in lazy means whenever you need, then only you can create objects. So here you can see it is creating if instance is null. So on demand it is kind of creating the instance. That's why it is lazy loading. And in case of eager loading, what will happen, this instance would be initiated initially. So the moment where it is, you can see here, it is just declared, but also it will be created here. So new keyword would be come there. So here this is the only difference between eager and this one, right? And then it is simply returning the string. Would you like to see protect these implicit in reflection and serialization issues? Yes, let's see. This is for advanced or very senior developers. This question would be asked like, would you, how would you prevent this using reflection and serialization creation of the different or different objects? So while traditional singleton implementations are effective for basic usage, they can be broken using advanced Java features like reflection, serialization, and cloning. Here is how you protect your singleton against these scenarios. So know where the for the singleton, know where the scenario should be like you can use or create another instance, basically two instance. What it is. Okay. So protection against reflection. What we are going to do? Protection against reflection. So reflection can change a private constructor's visibility to public at runtime, allowing new instance to be created. To fix, add a check in the private constructor to throw an exception to instance already exists. So in the private constructor reflection guard, what is the guard? If instance is not equal to null, throw new runtime exception. Use get instance method to get the single instance. So basically we can, if it is not an instance not equal to null, we are going to throw a runtime exception and it will not give it access to create a new object. Cool. Protection against serialization. So very important question for the interviews. Guys, very important one. And what we have to do here, you can see this read resolve. This method is asked multiple interviews. They ask about read resolve, and they expect seniors also, senior guys, senior developers to be aware of this read resolve. Cool. So what we have to do, the fix is implement the read resolve method. This hop tells the JVM, not hop, this hook tells the JVM to return the existing instance instead of creating a new one during the serialization. So this method implements the read resolve. It is a protected method, you can see, and its return type is object. So this method return the existing instance. What it is saying? Return get instance. So simply it is just returning the get instance method which you have written earlier. This method lazy loading. It is going to call this method simply. So inside the same class we need to write the read resolve. Protected object read resolve. This method signature and then return the get instance. And protection against cloning, how are you gonna protect it against cloning? If your singleton class extends a client that implements clonable, someone could create a copy of instance, right? The fix is override the clone method and throw a clone not supported exception. So you need to override this method object clone not supported, then throw new clone not supported exception. Right? Cool. So this is like about singleton design pattern. We covered the singleton design pattern. Let me go to the tab. So basically what we did here till here we covered singleton design pattern, which is very much popular and a favorite dessert of interviewer singleton. Cool. Now which one should we go? Let us pick. Let me see what are there. What is design patterns? This one, history of patterns, naturalism, criticism, classification of patterns. We have seen this one. Now we are on the catalog. Okay, this catalog was we were on this diagram. So singleton we cover. Now let's cover this factory model. Very important. Very important. So factory method is a creational design pattern that provides an interface for creating allows the class to enter the type ID. So you can see what is happening here. Factory method is a creational design pattern that provides an interface for creating objects in a superclass, but allows superclass, but allows subclass, not superclass, subclass to alter the type of object that will be created. Factory method is a creational design pattern, okay, that provides an interface for creating objects in a superclass. In superclass, it is going to provide an interface for creating objects, but allows subclass to alter the type of object that will be created. So it is saying subclass will have the power or will allow to alter the type of objects that will be created. So here in the diagram, look at this diagram, there is a factory. Since we are dealing with factory design pattern, so we need to understand there is a factory. You can see there is road logistics. This is the logistics department, and we have road logistics and sea logistics. So there is a river and some boats and ferries are there, and then there is road logistics. You can see there is some tempo and then some cranes are there, right? So this is the diagram. Now let's understand what is factory design pattern. Problem. Imagine that you are creating a logistics management application. The first version of your app can handle only transportation by truck. So the bulk of your code lives inside the truck class. We have a logistics apps, and then there is kind of all the vehicle type is on the truck, so all the code would be related to trucks class only, and that is great news. After a while, your app becomes pretty popular. Each day you receive dozens of requests from sea transportation companies to incorporate sea logistics into the app. Now, instead of truck, there are C department guys which want like you we want logistics for the same logistics app, but we also want our boats to be or our ferries to be included on that. So great news, right? But how about the code? At present, most of your code is coupled to the truck class. Adding ships into the app would require making changes to the entire code base. which is true somehow. Moreover, Moreover, if later you decide to add another type of transportation to the app, you will probably need to make all these changes again, which is then cool. As a result, you will end up with pretty nasty code, riddled with conditionals that switch the app's behavior depending on the class of the transportation methods, which is true. So what might be the solution? Think of it for a minute, just pause it. What might be the reason? Solution. The factory pattern suggests that you replace direct object construction calls using the new operator with calls to a special factory method. Don't worry, the objects are still created via the new operator, but it's being called from within the factory method. Objects returned by a factory method are often referred as products. Okay, so here now what happened, the solution, we have logistics, which we had, you can see in the diagram here, we have logistics, then we have road logistics, then we have sea logistics. And what it is suggesting logistics to have planned delivery and create transport. And for transport, you can see here we have road logistics and sea logistics. It is for road logistics, it is returning new truck, and for sea logistics, it is returning new ship, which is great. And transport T is equal to create transport. So this create transport method, you can see here what it is inside both road logistics and sea logistics. Cool. At first glance, this change may look pointless. We just moved the constructor call from one part of the program to another. However, consider this. Now you can override the factory method in subclass and change the class of products being created by the method. There is a slight limitation there. Subclasses may return different types of products only if these products have common base of class or interface. Also, the factory method in the base class should have its return type declared as this interface. So look at this diagram. What we are dealing with factory design pattern, and here you can see we have a transport, which and it has a method which is deliver, and two types of the vehicle mode. One is a truck and another is water vehicle, which is ship. Plus deliver, both are delivering, deliver by land in a box and deliver by sea in a container. Cool. So we have transport interface, and then we have two truck classes, which are concrete classes of implementing this interface transport. And then all products must follow the same interface. You can say, for example, both truck and ship classes should implement the transport interface, which declares a method called deliver. Each class implements this method differently. Truck delivers cargo by land, ship delivers cargo by sea. The factory method in the road logistics class return truck objects, and whereas the factory method in the sea logistics return the ships. It is talking about this class. A road logistic class, it is, you can see there is create transport, and what it is going to return, it is going to return new truck. And sea logistic, the same method, create transport method from the parent logistics, and it is going to return new ship. Very good. I hope you got the concept. Now look at this diagram. Logistics app, we have, there is transport. Everywhere there is transport interface, right? Remember this transport interface, and then there are two classes, concrete classes, truck and ship, right, which are implementing them. So here for road logistics, you can see there are road logistics, and it is create road logistics is creating truck objects, and then we have sea logistics, which is creating ship C objects, that is boat, ship actually. So this logistic app implements road logistics and sea logistics also. Basically what is happening, this logistics app is parent class, parent interface, and sea logistics implement or extends it, and road logistics extends it, right? Let me show here road logistics and then this one. Actually these are classes, so they implement it. Yeah, they implement it because they have classes. Okay, and then they create a new object. So where is our transport here? There is transport. So road logistics implement the transport also. Okay. So here you can see structure. The creator class declares the factory method that returns new products objects. It's important actually. Product is equal to new, then we have creator, then product B. Do not get confused into this one. I would not take you into this one so that you can get confused. I would say just struct method. This was good actually, and this is great actually. Just like now look here, real world example logistics system. Imagine you are building a logistics system. Sometimes you transport by truck and then sometimes ship. You directly create objects just like this. If type dot equals road, create road or new truck, otherwise new ship. It is suggesting it is a problem. What is the problem? Tight coupling, hard to extend, and if there is some aerial route like add airplane later, it violates open flow principle. So such solution you can see factory move object to certain object creation to subclass. So object creation we can move it to subclass. Step by step design you can see we have a transport interface which could have a method like deliver, and then the transport is there are two classes truck and ship which are going to implement the transport and then override this deliver method. Cool. So you can see the object creation is here. You can say deliver, and then let me have this creator object. Here we have abstract class logistics factory method which have create transport, which is going to create the transport. So this transport it is going to create, and in transport we have only deliver method, right? So let's create the transport. Here you can see plan delivery, and then transport is equal to create transport this method, and transport dot deliver two methods is having plan delivery and road logistic. There are two concrete factories. You can see road logistic and sea logistic just like in the diagram which we have seen in the diagram here only. Road logistics and sea logistics, road logistics and sea, which is extending logistics. override transport and create transport new shape. You can see new track new shape, and then there is the main method logistics, and we have logistics mode of C change to root. If mode dot equals root, you can see logistics is equal to mode root logistic. Yes, if it is plain, it is going to have plain logistic. If it is C, it is going to have C logistics, and then plan delivery. And once you click on plan delivery, it will deliver. So since here mode is C, and it will deliver by region C. So main method is kind of driver method. So we have logistics. You can let me remind you again. Show. We have abstract class logistics, and then there is abstract method, which is create transport, and then plan delivery, which is normal method, not an abstract method, but yeah, this class is abstract. So it is plan and delivery. And after creating transport, if you can see, it is returning transport object. Okay, the power is cut actually, guys. But yeah, we covered mostly our factory method. So today we covered two important creational design patterns. One is singleton design pattern, and another is factory design pattern. So the next video and the next live, what I would try कि हम जो है more of the design patterns जो है we would cover it. Cool. Yeah. So for now in the stream, have a great day. It is also going to be around 1 hour, but yeah, it was wonderful actually. And also, I want to try to say that stay in learning focus. Learning focus is very important because these days reels and all these are kind of distraction. They act a lot as a distraction whenever we pick mobile. What happens if we start scrolling with one reel, and then we continuously keep scrolling one after another, 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 and we lost. And whenever we see, whenever we come in, क्या कहते हैं होश में आने को, जब भी होश में आते तो देखते कि it's been an hour, it's been past. So that is actually very, I would say, distractful, and we have to always keep in mind like how to avoid distractions while studying, because this era is very kind of full of distraction, full of you, whether you open Instagram, Facebook, YouTube, Twitter, everywhere there is kind of, whenever you will open your half an hour, 15, 1 hour, 2 hour, 3 hours, sometimes 4 hours, it went. You start scrolling reels. If you go to some live or long videos, it takes the time. So I would suggest stay focused, and have some discipline. That is important actually while learning new things. Need not to hurry. I would not say कि you should be in hurry while reading, but I would say there should be a minimum pace. Like there should be a minimum pace. Otherwise, you will forget the things. Otherwise, you will forget the things. If too slow, that will also break the flow of the study. And if it is too fast, you are not going you are not going to grab the concepts. So if you remember, there is while studying there is a concept, T shaped learning. T means, if you say, there are two things, right? T, horizontal and vertical line. So T is the upper line stands for horizontal learning. Like, you should be aware of a lot of topics, kind of jack of all trades. But the vertical line, that is the deeper, like for any topic, how deep your knowledge is. So this era, we should not only focus horizontal learning. The importance is in the AI era actually, you have to be deep, kind of, I would say, not jack of all trades, but master of one. Master of one we need to be. So learn, learn and learn deeper actually, more knowledge on a single topic, that would be beneficial for this era actually. So guys, see you later. Bye bye. Happy weekend.